Out of these three, alpha and beta, and the third one gamma, you can classify these two into one type, and you can leave out this one, gamma, as a different one. On what basis? Well, we can say in both alpha and beta decay, your element is changed to another element. A parent nuclei and a daughter nuclei, they are different elements. So after the alpha decay, the uranium might be converted into thorium. Similarly, carbon after beta decay was being converted into nitrogen. So there always a change in the element after either alpha decay or beta decay. For the gamma decay, that's not the case. Your element essentially remains the same. It does not convert into new element. So this way, we can say that alpha and beta decay are, in some sense, they have this similarity. But so you remember in alpha and beta decay, in those two decays, we were writing the last constituent as the energy. Then the question would have been, what form of energy is that? And the answer was energy would be released in the form of gamma radiations. Like most of it, uh, a big percentage of that energy would be released in form of gamma radiation. However, there would be some other forms of energy as well. Always there would be some other forms of energy, but a large percentage of that energy would be released in the form of in the form of gamma radiations. So the gamma decay, it generally takes place along with the alpha and beta decay. So alpha decay, let's say there was an alpha decay. So alpha decay would be compensating for the loss of proton number and the loss of atomic mass. And since there would be release of gamma radiations as well, so we can say alpha decay and gamma decay are happening at the same time. So these are the three most important properties of the gamma decay. So let us write down a general equation. So for this one, the general equation is, let's say you have the element X, which is a parent nuclide, and with the atomic number, let's say Z, and the mass number A. So this element undergoes the gamma decay. Alright, let's refer to the gamma decay only. And we put a star with this one. This star represents the element X is unstable. So after the gamma decay, it will release the gamma radiations. So gamma rays would be emitted. We write down the gamma rays separately from here because this is what we get as a product. And what we are left with is not the element Y like we used to write previously. X now converted into Y because the element was changed into some other one, but in this case the element does not change into a new one. It remains the same. Hence the proton number and the atomic mass remain the same, or I should say because the proton number and the mass number remain the same, so it is essentially the same element. The only difference is now we don't put this steric here, we don't put the star here, which represents that your parent nuclide was unstable and the daughter nuclide after the emission of the gamma rays is now comparatively stable. But the proton number and the mass number remains the same, and hence your element X remains the same element. For example, if you consider this case here, this equation, so you have this element with the atomic number 94 and the mass number 240. After the emission of the gamma radiations, which is a high energy electromagnetic waves, matter of fact, electromagnetic waves with the highest energy,